Hello everyone, I'm Paul and today we're solving problem 3445, maximum difference between even and odd frequency 2. Here it says this is hard, but believe me, this is very hard, or at least for me. So here we'll go with the solution step by step. We're given a string s and an integer k, and we need to find the maximum difference between the frequency of two characters in a substring which has a size of at least k. Now we need to find this difference in the form of frequency at a minus frequency at b. And here a means any odd frequency and b means any even frequency. So finally we need to return this maximum difference, and here we have the constraints. First I thought about doing a double for loop on s and each time checking this stuff, and that's how I can find the maximum difference and then return this. But the problem is that s.length is more or equal to 3 times 10 to the power 4, so we need to think about something more efficient. And we also know that in s we have only 5 characters. We have numbers from 0 to 4. We also know that we need at least one character with an even frequency and another character with an odd frequency. So the even frequency cannot be 0 and the odd frequency can't be 0. Now, luckily for us, there is a solution that runs in big O of n time complexity, but it's very tricky. So here we'll go slow, step by step. First, there are a few concepts we need to review here, which are prefix sum and bitwise operators. So remember that for prefix sum, let's say we have this array, and let's say we want to get the sum for this. We can take the sum from 0 up to here and subtract the sum from 0 up to here, and that's how we get this part. So remember this. Now for bitwise operators, XOR operator returns true whenever we have different bits and returns false, meaning 0, when we have equal bits. So in this case we have 0, 0, so the result is 0. Next we have 1 and 1, so the result is also 0. We have equal bits. Next we have 0 and 1, so the result is 1. And finally, remember how to read these binary numbers. At each position we have 2 to the power of the current position. So first we have 2 to the power of 0, next 2 to the power of 1, next 2 to the power of 2. So in this case we have 2 to the power of 2 times 1, this is 4, plus 2 to the power of 1 times 1, which is 6. And here we have 2 to the power of 1 times 1, which is 2. So the decimal number 2 is 010 in binary, and decimal number 6 is 110 in binary. Let's say we have this string and k is 4. First we will take every possible combination of the characters we can have in the string, which are 0, 1, 2, 3, 4. So here we have roughly 25 combinations, and for each combination of different characters we will do the same process here until we find the maximum result. So let's say that we are iterating every possible combination, and we are currently at the point where a is 1 and b is 2. Now we will iterate this from left to right from index 0 with a right pointer, and we will have also a left pointer which is initially at index -1. And at each step we are checking if the current character corresponds to a or b, and if it corresponds to any of these we will update the count for this character. So we will have 2 more variables here, count for a, count for b, and these are initially 0. So we start here, we have a 1 and a is 1, so we can add a 1 to count of a's. Next we have another one, and count of a's now is 2. Next we have another one, so this is 3. Next we have another one, so this is 4. Now here we have a window of 4 and k is 4, so we might think about adding something to the result here. But the problem is that all 4 characters here correspond to A, and we don't have any character which corresponds to B. And remember, we need to have at least one character for each parity. A needs to have at least 1 in the count, and B needs to have at least 1 also. And given that we are using B for even, and even can't be 0, it must be at least 1, the minimum even after 0 is 2, so we need to continue until we have at least a 2 here. So we update the right pointer, and now we have 5 a's. Count of b's is still 0, so we continue. Now we have a 2, and b is 2, so we add to the count of b a 1, so this count is now 1. Now we have another 2, b is 2, so we add to the count of b another 1, so this is 2. And now we can add something to the result, because we have a window of 7 here, and 7 is greater than k, so this is okay. And we also have a count for evens, meaning the count for b, which is at least 2. In this case is 2. So now, while we meet these 2 requirements, we will update the left pointer. And we will also keep track of previous A and previous B. So let's say that here we have more numbers, and up to this point, up to L, we keep track of previous A and previous B. And up to the right pointer, we keep track of current A and current B. So let's say this string starts here, and here we have one number, another number, another number, and the rest of these numbers. If we want to take the result of this part, we can take CA minus CB, which represents all of this, and subtract PA minus PB, which represents all of this. And that's how we get this. So as you can see, this is almost like a big and complex prefix sum. So we are looking for CA minus CB minus PA minus PB. And remember, we are looking for the maximum result. So we want this to be as low as possible. Here we are trying to find the minimum. And to do this, we can store the difference for every state at left in a map. Let's see what I mean with state. The first value can be even, and the second value can be even. So both values are even. We will use 0 for even and 1 for odd. And this can be one state. Another state is the first value is even, the second value is odd. Another state is the first value is odd, the second one is even, and the final state is both values are odd. Now here we have binary numbers, and we can transform this into decimal numbers. So here we have 0, this is a 1, this is a 2, this is 3. So we can use this as the indices for an array. So we'll have this frequency array where initially every value is infinite, and the indices for each value correspond to every possible state. So now we want to store here the state up to this left pointer. So now previous A is 0 and previous B is 0. This means our current state is 0, 0. So here at index 0, 0 we store the minimum of this and PA minus PB, which is the difference up to this moment. So this is now 0. And next we update L. We have a 1, so we add at previous A a 1. Now we have 6 characters here and k is 4, so we need to continue with this part. Now this is even and this is odd, so the current state is 1, 0. So we are looking here in the array, and here we will store the minimum among this and 1 minus 0. So this is now 1. Now we update left, we have another 1, so this is now 2. So right now we are looking at the state even, meaning 0, 0. So we are looking here, and 0 is smaller than 2 minus 0, so we keep 0. Next we update left, we have another 1, so this is now 3. And here we have 4 characters, we still have 2 evens, we continue with this part. Now the current state is add even, meaning 1, 0. Here we will use the minimum among 1 and 3 minus 0, so we keep the 1. Next we update left, we have another 1, so this is now 4. And now we have 3 characters here, and 3 is smaller than k. Now here comes the tricky part, and this is why I think this problem is very hard. Now we need to take the current state, meaning the state we have at the right pointer. So here we have an add and here we have an even. This means we have the state 10. And we can use this to check if we have already seen a state with a different a but with an equal b. This means we are looking for state 0, 0 here. So we are fixing the even part and we are changing the add part. This is because we are trying to find a significant change moving only one variable. So if a right now is add and previously it was even, this means that in between we have some add a, and we are fixing the even part because this goes in steps of 2. So we check if the map at this index is different from infinity, which in this case it is, it's 0. And now we can add to the result the minimum of what we have in the result and CA minus CB, which is 5 minus 2 minus this value. So 5 minus 2 minus 0 is 3. So the result is currently 3. Now the right pointer is here, we have a 3 and we are not looking at 3's at this moment. We are only looking for 1's and 2's. And here we have 4 characters, which is fine, and the count for even is 2, which is also fine, so we can go to this part. The current state for the left part is even and even, so the state is 0, 0. This means we will replace the 0 with the minimum of 0 and 4 minus 0, so we keep 0. Now we update the left pointer, so now we have seen the 1 5 times. And now we have 3 characters here, which is smaller than 4. And now the current state for the right pointer is add even, meaning 1, 0. So this means we are looking for 0, 0. So the result is still 5 minus 2 minus 0, which is 3. Now the right pointer is here, we have a 2, and 2 corresponds to b. So we add to the count of b 1. Now we have seen the 2 3 times. We have 4 characters here, which equals k, so we are good to go. And we have 3 even, so we can go with this part. The current state for the left part is add even. So we are replacing this with the minimum between 1 and 5 minus 0, so we keep the 1. We update the left pointer. Now we have a 2 and 2 corresponds to b, so pb has a count of 1 now. Now we have 3 characters here, 3 is smaller than 4. And now our current state at the right pointer is add, so it's 1, 1. This means we are looking for 0, 1, and 0, 1 is infinity, so we keep our result, which is 3. Now we update the right pointer, we reach the end, and remember that all of this was only for when a equals 1 and b equals 2. We need to try every combination where we have different characters in 0, 1, 2, 3, and 4. So every time we're keeping with the maximum value in the result, and this is how finally we reach this result. Here I chose a equals 1 and b equals 2 just to show you which is the winner combination, but the algorithm will try every possible combination where a and b are different. Time complexity for this approach will be roughly big O of n, and space complexity will be big O of 1. As you can see, this is very hard, so I recommend you to think about this slowly. Now let's go with the code and hopefully you will get the idea. First, n equals length of the string. Result is minus infinity initially, because we are trying to find the maximum result. And now we'll create a function to get every state. We'll call this calc. This will take a and b, and here we will take the parity of a, meaning a bitwise and 1, and we also need the parity of b and 1, and we will move the parity of a one step to the left, like this. And now we need to join these two parities with a bitwise OR operator. And finally, we return this. So now we need to iterate every combination of a and b. So for a in 0, 1, 2, 3, 4, for b in 0, 1, 2, 3, 4. If a equals b, we continue. And now CA, CB are 0 and 0, and PA, PB are 0 and 0. So now we'll create the array to store the minimum differences on the left side for every state. So we'll call this best. This is an array with infinity for every index, so float infinity times 4. And now we can iterate the string with the two pointers, so left is initially -1, and for right in range n, if string at the right pointer equals to a, count at a plus equal 1. Similarly, if string at the right pointer equals to b, count b plus equal 1. And now, while r minus l is greater or equal to k, and cv minus pv is greater or equal to 2, this means while the size of the substring is greater or equal to k, and we have enough evens, meaning if the evens are greater or equal to 2, in this case left state equals calc PAPB, and now we need to update best at the current state, L state. So this will be the minimum among best, L state, and PA minus PB. And now that we have the information for the current state, we can update the left pointer. And if s at left equals a, PA plus equal 1, and if s at a equals b, PB plus equal 1. And now we can get the right state, so right state equals calc CACV, and now we can check if we have the corresponding value in best to update the result. So if best at right state XOR, and here we can use 2 in decimal or 2 in binary, which is 0b10. If this is different from float infinity, in this case result equals the maximum between the result and CA minus CB minus the best at right state XOR 2. Remember, we can use 2 or we can use this, which is 2 in binary. I'm using both just for you to know that both options work. And finally, we return the result. So this is it for the code. Now let's submit this and see if it works. Here I put I, and this is L, so let's correct this and try again. As you can see, this works and it's efficient. Remember, I think this is very hard, so I recommend you to take this step by step. And if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.